Okay, this is the third section of chapter 12. This is geometric sequences. Last class was arithmetic sequences. Alrighty. Okay, so now these are based on multiplication. So you can see that I take 1 times 3. 1 times 3 is 3. 3 times 3 is 9. 3 times 9 is 27. So the next term is going to be 3 times 27, which is 81. Alrighty, and then our next one, let's see, oh, it's getting lower. So if I divide this by 2, I get the next term. So 20 divided by 2 is 10. So my next term would indeed be 10. Now this one, the same number, it's just flip-flopping that negative. So I'm multiplying each one by -1. So this is going to be -1. -3 times -1 is 3. 3 times -1 is -3, etc. So since that's negative, my next term is going to be 3. Okay, now this one, harder to see that I'm multiplying it by 10. A lot of times, with decimals, it's easier if you write them as a fraction. So that's 1/100th, 1/10th, 1/1, etc. Okay, so we're multiplying the whole number by 10 each time. So 1 times 10 is 10 would be the next number. Okay, geometric sequence. The ratio of any two consecutive terms is constant. Now this is critical that you take note of this. It's one term over the term before. So if I have all my terms, it's going to be a sub 4 over a sub 3, not the other way around. A sub 2 over a sub 1. That's how we determine if they're geometric, is we find that ratio 2 or 3 different types and see if it's always the same. Okay, again, we have some standard formulas for recursive, and you've got to specify a sub 1 and explicit. These are easier because you don't have to simplify. Most of these are fine just how you write them. Whereas the arithmetic explicit, you had to simplify. All right, write both a recursive formula and a simplified explicit formula for the geometric sequence. First, we have to find R. We know it is geometric because they have told us it's geometric. So R is 2 over 4, which is 1/2. And a sub 1 is 4. So we use that straight up for our recursive formula. And it's merely R times a sub n minus 1. Our explicit formula, we plug in the a sub 1, which is 4, and then we plug in R, which we found to be 1/2, and then it's to the n minus 1, and we're done. We don't have to really simplify it, unlike with arithmetic, we did. Okay. All right, the graph of an arithmetic sequence consists of points that fall on a line with a slope d. Okay, so if this is my term number 1, so n, right? 2, 3, 4, 5, 6, etc. This would be the value that a sub n takes on. Okay, so if a sub 1 is 4, and it's arithmetic, actually I was not going to do that one in purple. Okay, we're going to put it in green. All right, if a sub 1 is 4, and it's arithmetic, so I'm adding, let's say, 3. This is going to go up 3 each time. So it's just a line with a slope of d. Okay, but geometric is very different. The graph of a geometric sequence consists of points that fall on the graph of an exponential function. Okay, so if 1 is 2, 2 is going to be something up here, and then 3 is going to be even higher, and 4, and you're going to end up with this kind of a shape. Right, this is a curve, it is not a straight line. All right, generalized explicit formula. All right, a generalized explicit formula for a geometric sequence. This is the one where we have two terms and term numbers. So we have a sub n and a sub k. We can plug it into this formula. So here they give us two formulas. So we plug this in. I've plugged in n and k here. N being 5 and k being 3. This gives us a sub 5 is 28. Okay, so a sub 5 is 28. A sub 3 is 7. 5 minus 3 is 2. So now we have to find a sub 2. So if I divide, not a sub 2, I'm sorry, r. I'm going to divide both sides by 7. I get 4 is equal to r squared. Now I square root both sides in 2. So r is 2. Now I noticed in your book that sometimes they go through and they'll say, oh, well, it's plus or minus 2. And though you can have a negative r, we will always use the positive, so you don't have to worry about that. If you want to be very meticulous, please, I'll accept the plus or minus, that's fine. But if it doesn't bother you, we're just going to, all I'm expecting is the positive r. So a sub n is equal to my first term. No, it's going to be a sub k, which was 7, times r2 to the minus 3. I'm sorry, I'm pausing because that's not correct. Hang on. Okay, I see where we're going. All right, what we're going to do is use our standard formula, and a sub n is a sub 1 times r to the n minus 1. Well, we know r, we don't know a sub 1. But I have two different a sub n's. So I know that a sub 3 is 7. So if I use that, a sub 3 is equal to a sub 1 times 2 to the 3 minus 1. Okay, so a sub 3 is 7. 3 minus 1 is 2. 2 to the 2 is 4. So this is times 4. Okay, so we're dividing both sides by 4, and that's going to give me a sub 1. So a sub 1 is 7 over 4. So now I can write my final a sub n is equal to 7/4 2 to the n minus 1. Okay. So that's my explicit formula. All right, a geometric mean. Remember we learned about arithmetic means. Geometric mean is the terms between two given terms of geometric sequence, just like we had arithmetic sequence, an arithmetic mean. Finding a single geometric mean between two numbers is the same as finding the square roots of their product. Okay, so let's see what that actually means. Okay. So we have a sub 1 is 3 and a sub 4 is negative 24. So we need two geometric means. That's why we chose negative 24 to be a sub 4. So we have a sub 1, and then we're going to look for 2 and 3, and we have 4. All right, so that gives us this following formula to find r. So if I divide by 3, I have negative 8 equals r cubed. Now, I have to take the cube root of both sides. I get negative 2 is r. So our r is negative 2. So a sub 1 is 3. A sub 2 is going to be 3 times negative 2, which is negative 6. A sub 3 is 3 times negative 6, or negative 18. And 3 times negative 18 should be our negative 24. And it's not. Hang on. I'm sorry. Sorry, that was a bad headache. Okay, I see what I did wrong. I'm sorry. Like I said, I have a headache. Okay, it wasn't supposed to be negative 6 I was carrying down. It was supposed to be the negative 2 each time. This was supposed to be the previous term. So this is a 2. This is negative 6, which does not give me negative 18, but positive 12. So this is positive 12, giving me negative 24, which it should, because I was told that the fourth term was negative 24. Okay. Okay, example 6. If a ball is dropped from a 100-foot tall tower and rebounds to 80% of its height on each successive bounce, how high does it bounce on the 10th bounce? So what it wants is, if we create a sequence for the height of the ball after a bounce, then we can plug in 10 and find a sub 10, which is our answer. So the ratio is 0.8 because it's 80% of the bounce, of the height. Our initial starting height, our a sub 1, is 100. Okay, so that means we have a sub n is equal to a sub 1, which is 100, times r, 0.8, to the n minus 1. So now if we look for a sub 10, is going to equal 100 times 0.8 to the 10 minus 1, which is 9. We plug that into our calculator, we get 10.74 feet. And that's the end of our lesson. All right, go work on your homework. Let me know if you need some help.